Let us now look some calculation with Weibull distribution model. Example, time to failure of a pipeline valve is assumed to have Weibull distribution with a shape parameter 2, that is beta, and a scale parameter 4000 hours, that is alpha. Our goal is to calculate the reliabilities of the valve for an operation period of 2000, 4000 and 6000 hours. Idea is to see how reliability is changing with time. Let's put the expression for reliability when Weibull distribution, when the time to failure are Weibull distributed. Here, exponent of t is a time to operation, alpha is a scale parameter, and beta is shape parameter. We have all the information to calculate reliability. Let us calculate the first reliability with 2000 hours of operation. So R for a period of 2000 hours becomes exponent of minus t is 2000, alpha we have 4000 hours, and raised to the power beta shape parameter of 2. This gives 0.5 raised to the power of 2. This becomes exponent of minus 225. And we can find this value very easily from any table or any from even internet. In good old days we used to look into the slide rules, some fixed tables, but now I usually log into my calculator and or from the internet I get the value of 0.778. So for a period of 2000 hours, reliability will be approximately 78%. Let's look at the what happens when time to operation is increased to 4000 hours. Exactly same way. Exponent of t is now 4000 divided by 4000, that is a scale parameter, raised to the power 2 because 2 is the shape parameters. We get a value of exponent of 1 raised to the power 2 is like a exponent of minus 1. If you remember from exponential model when we were calculating, we get the same value and it is coming to 0.367 roughly, means about 37% reliability. So just by increasing 2000 operation to 4000 hours, reliability almost becomes half. So reliability is decreasing with increasing time. And you remember when we said means there is an increasing failure rate. Now let us look for the third part. What happens when reliability becomes 6000 for a 6000 hours? That is exponent minus 6000 divided by 4000, that is scale parameter, and raised to the 2, that is shape parameter beta. This comes to exponent of minus 1.5 raised to the power 2, that is exponent of minus 2.25, and that value we can easily calculate again from some table or from internet or from mathematical table. It comes down to 0.105, approximately I can say 11%. If you look these three period of operation 2000, 4000, 6000, there is a dramatic decrease in reliability. So reliability is going down dramatically. Also, we'll recall, and we know, as I was discussing earlier, when beta is more than 1, there is an increasing failure rate, and in this case beta is 2, means there is an increasing failure rate, means with time reliability will be decreasing. We also recall, I said, when beta becomes equal to 1, there will be always this distribution get nearer to exponential distribution. So you will get the same value as you do in exponential modeling. And you note one more important thing. When t, time of operation, t becomes equal to alpha, a scale parameter, you always get the reliability 37%. And this is the characteristics used for developing graphical methods, etc. Take the example 2, where t is equal to a scale parameter alpha, and you get a 37%. So whatever the time of operation, when it becomes equal to alpha, you always get a reliability at 37%. Means at that point 63% of items are supposed to fail. And this is a very useful characteristics of Weibull distributions.